There was no warning. No radio crackle from the void, no alien broadcast interrupting our sleep. There was only a profound and perfect silence. Then a shadow fell across our star charts, a smear of light where nothing should be. It arrived without a sound, a ghost from another world, moving at a speed that defied the gentle gravity of our home. We aimed our telescopes. We ran our calculations. We gave it a name, a sterile scientific designation, 3I/Atlas. We called it a comet, a visitor. And in that simple act of naming, we made the single greatest mistake in the history of astronomy. We believed we understood what we were looking at. This object was a message, sent from a star system we will never see, written in a language of ice and dust, billions of years old. And for weeks, we were confident we were translating it correctly. We were so proud of our cleverness. We were so terribly, fatally wrong. What you are about to hear is not a simple history lesson. It is not a documentary you can scroll past. This is an unsealing, a cracking open of a vault that has been locked since the dawn of time. I am about to show you a truth that was not written in any human scroll, but was carved into a frozen rock older than our own sun, a rock that is, at this very moment, watching us. This is where I must ask you to make a choice. You can click away, and this story will remain a whisper, a secret you almost learned. Or you can stay. You can bear witness. So settle in, subscribe, because the doors to the archive are opening now, and they will not stay open for long. For all of our recorded time on this planet, we have been afraid of the sky. Our ancestors were not fools. They huddled in their huts and their new stone cities, and they watched the heavens with an intimacy we have lost. They knew the stars, the comforting, clockwork rotation of the constellations. They were a map, a promise that the world was orderly, that tomorrow would come. And then, one night, the map would be torn. A new star would appear, a star with a terrible, luminous tail, a hairy star. To them, it was not a ball of ice, it was a judgment. In 44 BC, a phantom light blazed in the skies over Rome for 7 days. Below, the body of Julius Caesar lay cooling on the Senate floor, riddled with the daggers of his friends. The people fell to their knees, certain it was Caesar's soul ascending to the heavens as a god. They called it the Sidus Julium, the Julian star, a warning, a sign of cosmic consequence. 11 centuries later, in 1066, the weavers of the Bayeux Tapestry stitched their terror into the fabric of history. There, in brown and gold thread, you can still see them. The Saxon king Harold slumping on his throne, his court pointing in horror at the sky. Above them hangs a furious star with a streaming tail. The Latin inscription reads, Isti mirant stella. They marvel at the star. They knew what it was, a prophecy of blood. Weeks later, William the Conqueror's ships landed, and the age of Anglo-Saxon England ended in slaughter at the Battle of Hastings. They saw these visitors as swords hanging over the world, as divine messengers, and we, in our modern arrogance, call it superstition. We smugly point our telescopes and talk of outgassing and sublimation. But what if they were right? Not in the particulars, not about angry gods or ascending souls, but right about the core feeling. The gut-wrenching primal instinct that when something new and powerful enters your world from the great dark unknown, it changes everything. Now one has come for us, and it is different. It is not from our celestial family. The comets of Caesar and King Harold were local messengers, born in the cold fringes of our own solar system. They were part of the story. This one is an outsider, a true alien. The astronomers who found it, working at the Atlas Survey in Chile, traced its trajectory. The line did not loop back to the cold darkness beyond Pluto. The line went straight, on and on and on, into the interstellar void. It came from the place ancient mariners marked on their maps with a single chilling phrase, "Here be dragons." And it carries the weight of that void with it. Our sun is a child, a mere 4.5 billion years old. The estimates for 3I/Atlas place its age between 3 and 11 billion years. It is a relic from a star system that may have been born, lived, and died before Earth had even finished forming. A fossil from a lost world. It travels at 58 kilometers per second. That is not a journey. That is a cosmic bullet. At that speed, it is not bound by our sun's gravity. It is a tourist, passing through. It will not stay. It is here to deliver its message and then vanish back into the eternal night from which it came. For the first few weeks, the message seemed simple. It was big, incredibly big. The initial readings of its brightness suggested a nucleus, a solid core of nearly 10 kilometers across. A mountain of ancient ice hurtling through our home. Astronomers were baffled. An object that large drifting through interstellar space should be so rare as to be statistically impossible. To find one wander into our system was like finding a single, perfectly preserved dinosaur bone washed up on a beach. It was a miracle, a beautiful, terrifying miracle.
We took its picture, we measured its size, we published our papers. We thought we had it. We thought we understood the first line of the message. Then, a single, clear image arrived from the Hubble Space Telescope. And the giant vanished. A giant does not simply vanish. A mountain of ice 10 kilometers wide, an object with the mass of a small city, does not just disappear from the lenses of our most powerful telescope. The laws of physics are not suggestions, they are laws. And yet the picture from Hubble was undeniable. Where there should have been a monster, there was a mote of dust. The first response in the scientific community was not excitement. It was a cold, quiet panic. A feeling that every calculation, every assumption made up to that point was built on a foundation of sand. The detectives had arrived at the crime scene, and the body was gone. The explanation, when it came, was even more unsettling than the disappearance itself. We hadn't been looking at the object. We had been looking at its ghost. Imagine a single lighthouse lantern on the blackest of nights, shrouded in the thickest sea fog. From a distance, you do not see the small, bright bulb. You see the enormous, hazy globe of light it creates in the mist. You might think the light source itself is huge. You would be wrong. That is what 3I/Atlas had done. It was surrounded by an immense cloud of dust and gas, its coma. And this coma was so astonishingly unnaturally bright that our ground-based telescopes had mistaken the entire glowing fog for the solid object within. The Hubble, with its diamond-sharp vision, pierced through the veil. It separated the fog from the lantern, and the lantern, the true nucleus of 3I/Atlas, was tiny. Not 10 kilometers. The new estimates ranged from a mere 440 meters to at most 5.6 kilometers. it had shrunk by as much as 95%. This was not just a correction, it was a complete rewriting of the creature's identity. It was not a lumbering, predictable giant, it was something small, secretive, and hiding in plain sight. This was our first clue that the comet was a shapeshifter, a trickster. In ancient Greek myth, they spoke of Proteus, the old man of the sea, a primordial deity who would change his form to a lion, a serpent, a flood of water to avoid being captured and forced to tell the future. Every time we thought we had our hands on 3i Atlas, it squirmed and became something else entirely. The investigation now had a new and urgent question. Why was the ghost so bright? What could make such a small object produce a coma of such impossible luminosity? The answer was buried in the past. A team of astronomers haunted by this new data had an idea. They began a forensic search, digging through the digital archives of other missions. They were looking for a ghost of a ghost, a faint smudge in old data that might have been overlooked. They found it in the records of TESS, the Transiting Exoplanet Survey Satellite. TESS was never meant to hunt for comets. Its job is to stare, unblinking, at vast patches of the sky, waiting for the subtle dip in a star's light that signals a planet passing in front of it. But in its endless vigil, TESS sees everything. And sifting through data from May of 2025, a full 2 months before the comet's official discovery, they found it. A faint smear moving silently across the star field. It was the first known photograph of our visitor. It was a pre-discovery, a clue from a witness that didn't even know what it had seen. And this clue would blow the case wide open. Because now, they had a timeline. They could track the comet's behavior as it moved through space between that first sighting in May and the official discovery in July. Physics has rules you can count on. As an object like a comet gets closer to the sun, it gets warmer and reflects more light. It gets brighter. There are equations for this, clean, predictable mathematics. Based on its trajectory, moving 0.9 astronomical units closer to our sun, the mathematicians calculated that its flux, the energy we receive from it, should increase by a factor of 1.5. Its brightness should have gently risen to a magnitude of 20.5. It was a simple, confident prediction. The prediction was a catastrophic failure. The data from TESS was unambiguous. The comet's brightness hadn't increased by a factor of 1.5. It had increased by a factor of 5. It had not gently risen to a magnitude of 20.5. It had surged to 19.28. This wasn't a candle turning into a lamp. This was a single ember miles away in a frozen wasteland, suddenly blazing with the light of a magnesium flare.
This wasn't just strange, this was physically wrong. An object this small should not be capable of producing that much energy. To do so, it must have been active, spewing gas and dust when it was still a staggering 6 astronomical units from our sun. That's a place out near the orbit of Jupiter, a realm of deep, brutal cold, where the sun is a distant pinprick of light, and most comets are nothing more than frozen, inert rocks. They only wake up, they only start to outgas when they get much closer to the sun's warmth. But 3i Atlas was not asleep. Out there in the dark, in the absolute cold, it was already raging. It was burning with a furious, impossible light. It was smaller than it should be. It was brighter than it could be. The only question left was the most terrifying of all. What in the hell was it burning? Every fire leaves a ghost, a whisper of smoke, an echo of ash. For weeks, we had watched the impossible fire of 3i Atlas, a small rock burning with the fury of a star. Now the time had come to analyze its smoke,
to put our hands into its ghostly trail and decipher the secrets in its ash. We were about to perform an autopsy on light itself. Our scalpel was the James Webb Space Telescope, a great golden eye floating 1,000,000 miles from Earth, designed to see the unseeable. On the 6th of August, 2025, that eye turned and fixed its gaze upon our visitor. Its instruments did not take a picture. They did something far more profound. They split the faint, ancient light from the comet's coma into a rainbow, a spectrum. This is the oldest magic of astronomy. Within that smear of colors are dark lines and bright lines, an intricate barcode. It is a signature, unique and inforgeable. It is the chemical soul of an object, laid bare. It tells you what it is made of, what it is burning, what it is lost. The first results were strange, but not reality-shattering. The oracle spoke of carbon monoxide and carbon dioxide, boiling off into space more eagerly than water. This was unusual. It hinted that the comet was a creature of a deeper, more profound cold than the ones born in our system. The dust it shed was also behaving erratically, fragmenting as it fled the nucleus, creating that deceptively brilliant glow. It was a complex beast, layered and temperamental, but it was still, we thought, a beast we could understand. The real confession came 2 weeks later from a mountain in Chile. At the Gemini South Observatory, a team of astronomers was watching the same ghost. In a quiet control room, high in the desiccated air of the Atacama Desert, Dr. Binyang was staring at a graph on the screen. It was a live feed from the telescope's spectrograph, a jagged, dancing line. And then, for a fleeting moment, she saw it. A spike, a sudden, sharp peak in a very specific sliver of the spectrum. The band for CN, cyanide. In the sterile language of science, this was expected. As a comet nears the sun, the heat sublimates its water ice. Trapped within that ancient ice are other molecules. One of them is hydrogen cyanide. The sun's brutal radiation cracks this molecule apart, and the CN fragment glows. It is a sign of a comet waking up, a sign that its heart of ice is finally beginning to melt. But this was not a sterile event. To see that spike appear on the screen was like hearing a voice from a tomb. It was the first time we had heard the comet's true breath, a poison breath, a ghostly exhalation carrying the scent of its birth billions of years ago in a place we do not know. For centuries, our ancestors pursued the dream of alchemy. They heated lead and mixed sulfur, desperately trying to understand the fundamental substance of the world. They failed, but their dream never died. It evolved. In that control room in Chile, their work was finally being perfected. We were using light as our furnace, and we were witnessing a transmutation not of lead to gold, but of matter into pure information. We were reading the prima materia of an alien world. And the recipe was wrong. As observatories around the world confirmed the finding, they began to count. How much cyanide was it releasing? The number was staggering, 800 sextillion molecules per second. But the true story wasn't in what was there. It was in what was missing. When a comet from our solar system burns, the cyanide is joined by other, more complex carbon molecules. The most prominent is dicarbon, or C2. The ratio of C2 to CN is a key part of a comet's identity. It tells us about the temperature and chemistry of the stellar nursery where it was born.
We searched for the signature of dicarbon in the light of 3I/Atlas. There was nothing. A void, a silence on the spectrum where a voice should have been. For every 100 molecules of cyanide it was breathing, it was producing fewer than 9 molecules of dicarbon. It was, in the stark language of the field, one of the most carbon chain-depleted comets ever observed. This was not a random quirk. The last interstellar visitor, Borisov, shared this exact same feature. This was a pattern,
the beginning of a profile for these interstellar fugitives. They come from a place where the building blocks of life as we know it are arranged differently. A colder place, a stranger place. Think of it. A message in a bottle thrown into the cosmic ocean billions of years ago. We had finally uncorked it. We had tasted the air from inside, and that air carried the scent of a different ocean entirely. The evidence was mounting. A body that shrinks and hides, an energy that burns impossibly bright in the cold, a chemical recipe with a key ingredient missing. The shapeshifter was revealing its nature piece by piece. It had broken the rules of size. It had broken the rules of energy. It had broken the rules of chemistry. Now it was about to break the light itself. Light is the oldest law. It is the universe's only constant. It travels at a fixed speed. It carries energy, and when it strikes a surface, it scatters in predictable ways. We have built our entire understanding of the cosmos on this single, reliable truth. We have studied the way light bounces off the rings of Saturn, the dust of Mars, the ice of comets from our own backyard. We know the rules. The physics is settled. On September 5, 2025, we learned that those rules do not apply to everyone. We discovered that 3I/Atlas is a heretic, an object that treats the sacred laws of optics as mere suggestions. The evidence came from a discipline known as polarimetry. It is a subtle science. Imagine sunlight with its waves vibrating in all directions as a chaotic crowd. When that light reflects off a surface, like the dust grains in a comet's coma, that crowd is forced into a line. The light becomes organized, polarized. Your sunglasses do this every day to cut down glare. Astronomers do it to probe the very structure of matter they can never touch. They look at a simple geometry, the line from their telescope to the comet to the sun. This forms what they call the scattering plane. They ask a simple question: is the reflected light organized in a way that is perpendicular to that plane or parallel to it? Perpendicular is called positive polarization. Parallel is negative. For decades, we have pointed our polarimeters at the sky. We have built a library of light. Every comet, every asteroid, every body in our solar system shows a familiar pattern. Their light is positively polarized. Even our last interstellar guest, Borisov, followed this rule. It was strange, but it was polite. It obeyed the local laws. 3/I/Atlas was not polite. The paper, published by a team led by Zuri Gray, landed like a thunderclap in the quiet halls of astrophysics. The data came from telescopes across the planet: Chile, the Canary Islands, Bulgaria, a global effort to stare at the comet's strange light. And they all found the same thing, something that should not be. The light from 3/I/Atlas had an exceptionally deep and narrow negative polarization branch. Let me translate that for you. The light reflecting from the dust of this comet was being organized in a way that is fundamentally different from any other small body we have ever observed in the history of science. It was not just negative, it was aggressively negative, strong, localized. It was as if the very dust grains themselves possessed a structure, a texture, a porosity so alien that it twisted light into a shape we had no name for. This was not like finding a new type of rock. This was like traveling to a new continent and discovering that the water there flows uphill. In the history of science, there are moments of beautiful failure. Moments when an observation or an experiment returns a result so profoundly wrong, so contrary to all expectation, that it shatters the old world and forces us to build a new one. The discovery of radioactivity, a mysterious energy that seemed to emerge from nothing, broke the laws of conservation. The Michelson-Morley experiment, which failed to detect the invisible ether that all of physics presumed filled space, created a crisis so deep it took an Einstein to solve it. This was one of those moments. The light from 3I Atlas was a beautiful, spectacular failure. It told us nothing about what the comet was, but it screamed at us about what it wasn't. It wasn't like us. It wasn't from here. And it was made of something that may not exist in our corner of the galaxy. The Greek myth of Medusa tells of a creature so horrifying that to look upon her face was to be turned to stone. For centuries, our theories of planet and comet formation have been our heroes, our Perseus, confidently exploring the cosmos. On that day in September, 3I Atlas became our Medusa. We looked at its true nature through the reflection of its light, and our most cherished theories turned to stone. They were frozen, inadequate, broken. We do not know what kind of dust can do this. We have no models for it. We have no samples. It places 3I Atlas into a unique class of one, an anomaly of physics masquerading as a comet. You see the arc of this story now. A shrinking giant, a furious, impossible glow, a ghostly breath of poison, and now a light that bends the wrong way. The universe was presenting us with an object that violated our understanding of matter, energy, and optics. It had created a profound and terrifying vacuum in our knowledge. A vacuum of knowledge is a dangerous thing. It is unstable. It is hungry. And when science leaves a question of this magnitude hanging in the silent air of the cosmos, something will always rush in to fill the void. Not a new theory, not a patient hypothesis, but a story. A story as old as humanity itself. The story of gods from the sky. Of visitors. Of aliens. The story found its champion in a man named Avi Loeb, a renowned Harvard astrophysicist, a brilliant, restless, and deeply controversial mind who looked at the cascading series of impossibilities surrounding 3I Atlas and saw not a natural phenomenon, but a deliberate intelligence. He heard a signal in the noise. He saw a spaceship where the rest of the world saw a comet. His argument at first was seductive. It began with the comet's original, mistaken size. An object 10 kilometers wide from interstellar space, he argued, was so statistically improbable that its arrival could not be an accident. The universe simply doesn't make enough material to throw mountains between stars with such frequency. It had to be a probe, a scout, something sent. Then, just days later, he doubled down. He published a paper with a title that burned away all scientific subtlety. The Interstellar Object 3I Atlas, Alien Technology. In it, he referenced the dark forest, a chilling solution to the Fermi paradox, which asks why, in a universe so vast, we are so alone. The dark forest theory suggests we are not alone at all. The universe is teeming with life, but it is silent, terrified. Every civilization is a hunter, hiding in the shadows in its own solar system, listening. And the first to make a sound, the first to reveal its position, is the first to be annihilated. In this terrifying cosmic wilderness, Loeb suggested 3I Atlas might not be a friendly visitor. It might be a hunter's arrow. It is a beautiful, terrifying story. It has villains and heroes and the fate of humanity hanging in the balance. It is the kind of story that travels fast, that sets the media ablaze, that makes you look at the night sky with a fresh, electric spike of fear. The problem with a beautiful story is that a single, ugly fact can kill it. And the facts were already piling up. Loeb's central premise, the impossible size of the comet, was built on the first flawed measurements. He was building a cathedral of speculation on a foundation of sand. When the Hubble data came in, revealing the comet's true, much smaller size, the foundation crumbled. Yet Loeb continued to build. He mentioned the Hubble images in his later writings, but still clung to the outdated numbers that his hypothesis required to survive.
This is not the mark of science. It is the mark of belief. And it is a pattern we have seen before. A century ago, a wealthy Bostonian astronomer named Percival Lowell peered through his telescope at the planet Mars. He saw, he was certain, a vast and intricate network of canals, straight lines, intersections, oases. They were, he declared, the work of a dying Martian civilization, desperately channeling water from the polar ice caps to save their world. His maps were intricate. His books were bestsellers. He ignited a global fascination with life on Mars. But the canals were not there. They were an illusion, a combination of a flawed telescope and the powerful human tendency to see patterns in chaos, to see intelligence in the random smudges of dust on a distant world. Lowell saw what he wanted to see. His beautiful story was killed by the ugly fact of a better telescope. Loeb's other claims of engineered maneuvers and non-gravitational acceleration were likewise dismantled by the patient, unglamorous work of orbital mechanics. Geoscientist Occam Elsinhari Huck demonstrated that the comet's path could be perfectly explained by natural dynamics. The alien spaceship, it turned out, was flying exactly like a comet. The great irony is that while the world was distracted by the seductive cinematic story of alien hunters, a piece of real, baffling evidence came not from a Harvard professor, but from two amateur astronomers in Namibia. On a clear night in September, Michael Jager and Gerald Ryman took a photograph of 3I Atlas. The image was stunning. The comet was glowing with a vibrant, unmistakable green hue. This beautiful, ghostly green is not a total mystery. Comets in our own system do it. It happens when sunlight energizes diatomic carbon, C2, causing it to fluoresce. It is a normal, predictable chemical reaction. Except for one thing. We had already tasted the comet's breath. We knew its recipe. And we knew with absolute certainty that this comet was severely, profoundly depleted of dicarbon. It should not have been green. There should not be enough C2 in its coma to produce that color. And yet, there it was, a paradox captured on camera, a genuine, inexplicable mystery that was far stranger than any story of alien technology. The shapeshifter had changed its form again, revealing a new contradiction, a new impossibility. The alien story was an echo in a chamber of our own making, a reflection of our own hopes and fears. But the green glow, that was a whisper from the comet itself, a new line in its unwritten message. It was a reminder that we did not need to invent monsters to be awed by the sky. The truth, in all its cold, bizarre, and contradictory glory, was more than enough. On the 30th of October, 2025, our visitor took its bow. It reached perihelion, its closest and most violent encounter with our sun. Hidden from our view by the star's blinding glare, it endured its trial by fire, a climax happening offstage. For the astronomers who had tracked it, chased it, and argued over it, this was a moment of supreme tension, a held breath lasting for weeks. This was not an ending. It was an intermission, a period of silence while the universe decided the comet's fate. Would it survive the sun's fury,
Or would the fragile, dirty snowball, as one astronomer called it, break apart? Would it shatter under the strain, exposing a fresh heart of untouched primordial ice to the sunlight, triggering a new and final outburst? As it re-emerged from behind the solar curtain in early December, scarred and changed, but miraculously intact, we prepared for the final act. Our great observatories, Hubble, James Webb, and others, turned their eyes back to the departing guest. We were poised to read the last page of its story. And we were left to finally confront the questions that haunted the entire investigation, the specters of the last 6 months. A body that shrinks to reveal a furious spirit. A fire that burns with impossible energy in the absolute cold. A poisoned breath made from a recipe with a key ingredient missing. A paradoxical green flame which has no right to exist. And a light that breaks itself, scattering in a way that violates the known laws of our world.
These are the pieces of the puzzle. This is the legacy of 3I/Atlas. It came to us as a test of our instruments, of our theories, of our ability to separate the signal from the noise and the science from the story. For centuries, we have looked for a message from the stars. We built radio telescopes to listen for whispers. We sent our own messages, painstakingly curated. In the 1970s, we launched the Voyager probes, each carrying a golden record, a self-portrait of humanity, etched in gold, the sound of a mother's kiss, the music of Bach, greetings in 55 languages, a perfect, hopeful, and deeply arrogant message, assuming someone out there would understand or even care about our art and our emotions. It was our attempt to tell the universe our story. We were so busy trying to talk, we forgot to listen. 3I/Atlas is the universe's reply, not a golden record, but a dark record. Not a curated portrait, but a raw, unintentional core sample of another world's creation. Its message is not in a language we can learn. It is written in the physics of its being. And that message is far more humbling and far more profound than any we could have sent. Our efforts to understand it are like the struggle of the scholars who first faced the Rosetta Stone. They saw 3 scripts, hieroglyphic, demotic, in Greek, carved on the same rock. They knew it was the key, the code breaker that could unlock the lost civilization of Egypt. But for decades, it was just a stone, a collection of beautiful, incomprehensible symbols. Our data, the polarimetry, the spectrometry, the astrometry, are the scripts on our Rosetta Stone. We can read the individual lines, but we cannot yet make them speak as one. We do not yet have the key to translate this object's true history. But we know what the first line of the translation says. The comet's unwritten message is this: the universe you thought you knew is a comfortable fiction. It is the story you tell yourselves in a single quiet room while the library of creation, with its infinite unread volumes, burns silently all around you. The stories written in other star systems, with other chemistries and other physics, are stranger, more complex, and more beautiful than you have ever dared to imagine. You are not at the end of your journey of knowledge. You are not even at the beginning. You are simply, finally, looking up and realizing the door is open. History teaches us one powerful lesson: nothing lasts forever. Not empires, not kings, not even entire civilizations, but stories. Stories only survive when they're passed on. So if you've made it this far, don't just be a silent traveler through time. Hit that like button, subscribe to this channel, and turn on notifications, because if you don't, this story may vanish into the noise just like the civilizations we speak of. Don't let it be forgotten.